Hey guys, welcome back to lecture series on Z transform. In my today's video, I'm gonna explain to you all properties of a Z transform, which is similar like our Fourier transform, that linearity property, change scale property, shifting property. So we are going to take similar properties, but these are little different here in Z transform. So I'm gonna explain to you all first here linearity property. So if you're interested to see this more video, guys, go and check in my I button here. You will get my complete lecture series, or you can check in my description. Okay, so in the description you will get my entire playlist based on the linear differential equation with the constant coefficient and Fourier transform, Fourier sine, cosine and their inverse transform, and plus Z transform. Okay, so here let's get dive into our today's lecture. I'm going to explain to you all linearity property first, and we go for solving some example later on. Okay, yes, so linearity property, how the linearity property we can define. Now see that under Z transform, whenever we have combination of a more function, or if you have more function in a Z transform, that time we apply linearity property. Now let me write the linearity property, so it will be helpful for you all to understand. So Z transform over A into f of k. Okay, A into f of k. A considered a constant here. F of k is a function for our Z transform. Okay, plus b into g of k. Okay, b is a constant, g of k is a function for our Z transform. Curly brace is complete. Okay, so I'm going to write that Z transform. Now see that how I'm going to write. Take a constant outside. Z transform. Okay, Z transform of f of k under curly braces take. Okay, a into Z transform of f of k plus b into Z transform of g of k. Okay, this is the g of k, g of k, bracket complete. So this g of k I written here, g of k, b into Z transform of g of k. Okay, so keep a as it is, Z transform f of k, so we write capital F of Z. Okay, we know that Z transform f of k can be written as capital F of Z, or Z transform denoted as capital F of Z, and b Z transform with g of k, b it is another function, so consider it as the g of k. Okay, so a into f of Z plus b into g of Z. Okay, not a k guys here, g of Z here. So this one is the linearity property that we can write. A in Z transform of A into f of k plus b into g of k can be written as constant A outside, Z transform of f of Z plus Z transform of g of Z. Okay, yes, actually f of k, this is the notation only. We denote Z transform as f of Z and Z transform for g of Z as a capital G of Z. Okay, this is just notation, don't get confused. Okay, we go for some of the example based on this property here. So here we are going to solve one example. Find the Z transform of a sine function. Okay, so we are going to solve cosine function later on, but just go for the sine function first. Okay, yes, we want the Z transform of sine 7k plus 5. Okay, Z transform of sine 7k plus 5. It is way easier, guys, but as we can see that sine a plus b format it is given. Okay, so we don't have directly sine a plus b format for our Z transform. Okay, so let me write the formula first for Z transform of sine alpha k. Okay, so we already learned, this is the formula, guys. Okay, this is the formula, Z transform of sine alpha k and when k greater than 0. Okay, sine alpha k and k greater than 0 can be written as Z sine alpha upon Z square minus 2Z cos alpha plus 1. Okay, we write Z square minus 2Z cos alpha plus 1 and modulus of a Z is greater than 1. Okay, this one is our Z transform for sine alpha. Okay, but as we can see that this one is for only alpha k, not alpha k plus d, alpha k plus beta. This format is not there, but in our Z transform we have given sine of 7k plus 5. Now see that carefully how I am going to solve. Okay, sine of 7k plus 5. Okay, sine of 7k plus 5, I'm going to solve this one here. Okay, that means sine of a plus b. Okay, we know that sine of a plus b can be written as sine a cos b plus cos a sine b. Okay, this one is the expansion for sine a plus b now. Okay, sine a plus cos b, then sine 7k plus sine a cos b. Okay, cos b sine 5 cos 5. Okay, sine a cos b plus cos 7k sine 5. Okay, now see that sine a cos b plus cos a sine b, sine a plus b expansion. Okay, so that expansion I am going to replace over here. Okay, so now see that sine 7k plus 5, put it here. So I'm going to write this one as a z transform under curly braces sine 7k okay, cos 5 plus cos 5 plus cos 7k sine 5. Okay, so I replace this value sine 7k plus 5 instead it here. Okay, yes, curly braces complete. Now let's apply the z transform. Now see that z transform, it is applicable on sequence, and when sequence matter in our z transform, whenever some k type of the term possible here, cos 5 it is completely constant na. So if cos 5 it is completely constant, we take it outside as our linearity property. A into a, it is a constant, so a behave here cos 5 and second b behave here sine 5. So take that constant outside and take the z transform of first sine 7k and z transform of second here z transform of g of k. Okay, so we have to apply linearity property here. Okay, yes, now see that carefully how I am going to write. Cos 5 it is constant na? Take it outside, cos 5 constant outside under, now see that multiplied by z transform of sine 7k. Okay, so we want the z transform sine 7k under curly braces complete. Okay, plus what we have between plus sign, so take that plus sign here. Sine 5 it is constant na? Take it outside, sine 5 outside here under bracket z transform of under curly braces cos 7k, curly braces complete. Okay, now see that how I have written over here guys. It is way easier, that cos 5 constant outside, z transform of sine 7k, sine 5 outside, z transform of cos 7k here. Okay, yes, this is the expansion of this term. This step I written as this way. Okay, yes, now we know that sine alpha k and cos alpha k can be written as, now see that sine alpha k I written over here, so I can put this value directly into it, but I want the cos alpha k now. So we know that the cos alpha k, z transform of a cos alpha k. Okay, z transform of cos alpha k and k greater than 0. Okay, z transform of a cos alpha k and k greater than 0 can be written as z into, okay, z minus cos alpha, z minus cos alpha. Okay, z into z minus cos alpha, denominator it remains same everywhere, z square minus 2z cos alpha plus 1 and a modulus of z greater than 1. Okay, this one is z transform of cos alpha k. Okay, need to remember guys this one, it's very much important. Sin alpha k cos alpha k z transform, denominator z square minus 2z plus cos 2z cos alpha plus 1, it is same everywhere. Okay, in a sin alpha k, in a cos alpha k, they are hyperbolic and hyperbolic sine, hyperbolic cosine. Okay, it remains same. So apply these two form over this term. Okay, so cos 5 keep as it is. I'm going to write cos 5 as it is over here. Okay, z transform of a sine 7k. So what is alpha? Sine 7k, alpha is a 7, so z sine 7. So I'm going to write a z sine 7 denominator by z square minus 2z cos 7 plus 1, z square minus 2z cos 7 plus 1. Okay, yes, this one is a z transform for sine 7k plus again sine 5 as it is outside here. Okay, sine 5 outside here, z transform of cos 7k. What is the cos 7k? Now see that alpha is a 7, so cos 7k, so replace alpha as a 7, z into, I'm going to write z into z minus cos 7 bracket complete, total divided by z square minus 2z cos 7 plus 1 bracket complete. Okay, So this one is our required Fourier, required Z transform of cos 7k, okay, and it is a required answer, okay. So we can see that denominator same, you can take it together, take numerator to the power addition, okay. So this one is our required answer, guys, okay. I hope you all have understood, not that difficult. First we learn here linearity property, and I applied that linearity property for solving this example, okay. Yes, just I applied this linearity property here for solving this one, this term to this term, okay. Yes, I apply plus one more result, sin a plus b, sin a cos b plus cos a sin b, okay. So this one is our entire Z transform for our sequence. I hope you all have understood, guys. Nothing it is difficult, it is way easier solution, okay. Even after, if you found anything difficult, guys, let me know in my comment section, okay. And if you have any doubt, difficulty, also let me know, or any other challenging question, let me know. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture. In my today's next lecture, I'm gonna explain to you all more example, okay. So thank you everyone.